Here we go. Let's pick a problem here. Here we go. I might have assigned this one. I don't know. But here's what we're doing. It's not that hard. Here I go. I was all set to go and I couldn't find my damn pen. All right. Let's get started here. Now here's all we do. Let me maximize this a little bit more. Zoom in just a touch. Now my hand's going to be all big and hairy, but that's okay. All right, so what do we got? We got a voltage. Voltage is 6 volts down here. So that means there's going to be 6 volts across here and 6 volts across here. Well, that's kind of nice because if these are all the same, if these are the same, now notice what we're going to do is we're going to shrink this into one circuit or one, add those two, and then because they're in series, and then treat them like they're in parallel. So for circuit A, this is what it looks like. Circuit A, I'm going to take what's the ohms? 9, 9, 9, 9, 9. So in circuit A, top row, I get 9 plus 9 is 18. Second row, bottom row, equals 9 plus 9 is equal to 18. Okay, so I've got 1 over 18. 1 over 18 plus 1 over 18 is equal to 2 over 18 to the minus 1 is equal to 9. So this one, the entire ohms, I've got 4 9 ohm resistors in there, but because they're in parallel and in series together like that, then determine the total power. Okay, so we know that power is equal to V squared over R. So I've got V, which is 36 over 9, so the power is 4.0 watts. That's how we do that one. The only one that might be kind of tricky, but none of these are that tricky. So what we'll do is, notice we've got so what's happening? We've got a current coming out of here, hits here, we've got I1 going through here, we've got I2 going through here, but we also, once again, 9 plus 9, 9 plus 9. So this is just this, once again. We'll just pop it in there. We already found out that that's equal to 9. So this is 9 plus 9, so that's 18. And so the power in circuit C, did you see what I did there? Or you know how to do it now. So once again, I'd take 9 plus 9, 9 plus 9. So I get 18, 1 over 18 plus 1 over 18 plus 1 over 9. I mean, it's not that hard. All right? So there's that one. That's another problem. I had a tricky one. Where'd it go? Okay. Let's look at this guy. All right, now, I'm going to do something. I'm going to change this to 12 volts for right now, and this to 57.6, and this to 57.6, and this to 57.6. There's a method to my madness here. We'll come back and do the problem normally. Determine the power supplied to each. We need to find the current that's flowing through here, I, because we know that P is equal to I squared times R. Or we can also find the voltage drop that's going, because we can get I times R. But I need to find the current that's going through each one of those. So I know that big I is coming out of here. And I know this is I1 and this is I2, and then they're coming back together again here, and they're going to be total of I again. Okay? But I want you to bear with me for a second. Watch this. I've got this circuit construction thing. God damn. Sorry. I've already done this security thing once. So annoying. Open anyway. Open. Tight ass little thing. So here we go. We're going to build this circuit. So bear with me as I build this circuit. Is it legal for me to do this now? Oh my! I thought I told you. So I'm wasting your time. That is just such bullshit. Sorry. God. Oh, I am angry. Okay, so but you see how this is done. Okay. I'll get what the total current I is. Okay. Then we're going to look at something. Okay. So let's do an analysis here. So I've got 576. So let's get the 576 is going to go into 576 over 576. So I can figure out the total current there. So I've got 576 going into 1 over 576, which is 2 over 576. 576 divided by 2 gives me, I need my good calculator, 576 divided by 2, 288 is what this total resistance equals. So I got 288 plus 576 is equal to 864 ohms. Okay, so that's if I broke this circuit down to look like this. $120, 576, and 864. Oh, and 288. Okay. Now, I know the current going through here is the total, is the big I. I know the current going through this one is actually I1 plus I2. But actually, we know that I1 equals I2. Don't we? Yeah, we do. Because these two resistances are the same. So I1 and I2 are equal to each other. So 2I1 equals I. So it's just this current is half of whatever that one's going to be. So the total current, I total, is equal to 120 over 864. I1 plus I2 is equal to I total, and we know that I total are equal to each other, so 2I1. You can figure out that, right? Cool beans. That's a good problem. Now let's look at internal resistance real fast. It says when a light bulb, and then we'll look at Kirchhoff's law. When a light bulb is connected across terminals of a battery 24 watts of power, a voltage of 11.8 exists. Okay, so now I can figure out what the current is, between which has an internal resistance 0.1. What is the EMF of the battery? In other words, what's the total? In other words, what is Radio Shack or O'Reilly Auto Parts selling me this battery for? Okay, so here we go. Oh, this is so nice. So I know that power is equal to I times V. Okay, so now, and I know that V that's going through there is equal to 11.8. So now I know the current. I is equal to 24 divided by 11.8. Okay, we'll just leave it there. But I also know that the EMF is equal to the voltage, this guy that it feels, plus I times that internal. So the tricky part was to find I. What's the internal? There's 0.1, and I know 11.8. Okay? So the EMF then, or we also do V is equal to the EMF minus that internal resistance, because this is the resistance that's pushing against the battery. It's pushing against that internal EMF. So that's the way you do that one. Okay? All right, out here.